Today we're going to look at graphing parabolas. The standard form of the parabola that we're going to use is ax squared plus bx plus c equals 0. And when we graph it, we're going to call it a parabola. And a little trick we can learn, skipping down to number 3, is that when we have that form of ax squared plus bx plus c equals y, we can know that the vertex of it is simply going to be negative b over 2a, and then whatever we would get when we plug negative b over 2a into our equation. And so that's going to be the middle of the graph. And then we can know our scale factor is going to be a. So that's how much it's going to be squeezed or stretched out. So like if it had a high scale factor, it looks something like that. If it has a small scale factor, it would look more like that. And we don't need to really look at that so much when we're graphing though, because we can just kind of plot points, and that makes it easier for us. So if we do some examples with that, if we go down to number 4, and we use the 2x squared plus 8x plus 6 equals y, we can know that our vertex is going to be negative b over 2a. So it's going to be negative 8 over 2 times 2, or just negative 2. Plug that into here, you get that the y value is negative 2. So our vertex is going to be negative 2, negative 2. And then from there, if we want to graph it, we could just start here at our negative 2, negative 2, negative 2, right there. And we can make a table and just plug in more values. So you had negative 1, plug that into the original equation, and you'd get 0. Then you go to 0, plug that in, you'd get 6. You go to 1, plug that in, you'd get 16. And we know they're going to be symmetrical because that's how parabolas work. So you got your negative 2, negative 2, then you got your negative 1, 0, then you got your 0, 6, and you got your 1, 16. And then you just do the same thing on the other side. And so you get the parabola, looks just like that. And of course, they go on forever. And so, since you know your form, you know how to get the vertex, and you know how to get the vertex, and you know how to plot points, you can graph the parabolas just like that. And so another thing we can look at is maximum and minimums. And of course, the maximum point of the graph is just going to be the highest y value. The minimum is going to be the lowest y value. The x-intercept is going to be when it crosses the x-axis and y equals 0. And the y-intercept is when x equals 0. So we can use that to solve for those. And when we're looking at whether the graph has a maximum or a minimum, when the graph looks like this, when it has a positive scale factor, it's going to have a minimum down there. And it's not going to have a maximum because it goes on forever. And when it has a negative scale factor, it's going to have a maximum. And it's not going to have a minimum because it goes down forever. And that maximum and minimum is always just going to be that vertex point. So since we know how to find the vertex, we already know how to find the maximum or the minimum. And so we're just going to worry about the x and y intercepts. So to do that, the easiest one is the x-intercept, or the y-intercept on number 5. All you got to do is plug in 0, because the y-intercept is when x equals 0. So you have this, and all you have to do is make x equals 0. So that's some pretty easy math. That's 0, plus 2 equals y. I think that's 2 equals y, or y equals 2. So our y-intercept is just going to be when x equals 0 and y equals 2. Done. That's it. And that's going to be our y-intercept. And then if we're thinking about max and min, we can find the vertex, negative b over 2a, negative 3 over 14, and then plug that into the original equation. And the y-coordinate is going to be 47 over 28. And is it going to have a positive or negative? what is it a max or a min? It has a positive scale factor, so it's going to look like this, which means it has a min. So it's going to have a minimum at that point right there. That point. And then, so moving on to how to find the x-intercepts. A little bit more difficult. So our first option is factoring. That's our best bet if it seems easy enough. So if we have something like this, we can look at it, and we can factor that into x plus 3 and x plus 2. And then solve both of those for x. Or solve both of those, for x, because they both equal 0. So then you get x equals negative 3 or negative 2. And so those are the x-coordinates of our x-intercepts. And remember, on the x-intercepts, y equals 0. So our x-coordinates are going to, or our coordinates of our x-intercepts are going to be negative 3, 0, and negative 2, 0. And again, some practice finding the min or max. We can get the vertex, negative b over 2a, negative 5 over 2 for the x-coordinate, and whatever we get for the y here. And most importantly, it's going to be a max or a min. It's got a positive, so it's going to look like this, and it's going to have a min. And then, so moving on, the second method of finding the x-intercept is the quadratic formula, which is much better in my opinion, because if you're feeling lazy and you don't want to factor, you can just plug and chug, and it's all good. So it looks like this. And so if we have an equation like number 7, it's first off all jumbled up. So they give us 3x minus 3x squared plus 3 equals, let's see, that one, equals y plus 1 minus 2x and plus 4. And so from that, we can combine like terms pretty easily, especially if I color code them properly. So we already have our negative 3x squared on this side, and then we can add 2x to both sides to get plus 5x, and then we can subtract 5 from both sides to get minus 2, and that would equal our y. So now we have our a, b, and c. So if we put that into the quadratic equation, I'm going to have to go to the next page, unfortunately. X equals negative b plus minus square root of b squared minus 4ac over 2a. We come back. We remembered a was negative 3, b was 5, c was negative 2. A equals negative 3, b equals 5, c equals negative 2. Come back here, check and make sure we got it right. Negative 3, 5, negative 2. Negative 3, 5, negative 2. All right, now we just got to plug it in. So x equals negative 5 plus minus the square root of 5 squared minus 4 times negative 3 times negative 2. All over negative 2 times 2. Simplify that, and we can get that negative 5 plus minus the square root of 1. So I don't even know why I wrote that, because we can just write 1. Plus minus 1 over negative 6. Because this was supposed to be negative 3. And so if we take that to the next page and simplify that even more, x equals negative 5 plus minus 1 over 6, we can get that x equals 2/3, or 1. And so those are going to be our those are going to be the x-coordinates of our intercepts. So we're going to have 2/3 and 0 and 1 and 0. And so that's how we find our x-intercepts. So as a quick review, to just graph a quadratic, all you've got to do is find the vertex, which is negative b over 2a, and f of negative b over 2a. And then you just set up a table, and the rest is history.